Hello everybody, and once again welcome to my channel Pankaj Sir's Echelon Tutorials. And in this today's session, uh, we are going to discuss a concept of chemistry for the IGCSE students. And the name of this concept is limiting reactants. It's a very important concept, and some stoichiometric numericals or problems, you cannot solve without using this particular limiting reactant constant. Okay, so first I'm going to make you understand what is the meaning of this limiting reactant. Second, I will give you some example of a chemical reaction actually, and in that chemical reaction, I'll explain you how a limiting reactant, what is a limiting reactant, what is the role of that limiting reactant that we are going to discuss in this today's session. So to start with, what is the meaning of limiting reactant? Okay, so here we go. So the meaning of limiting reactant is it is that reactant which is used up first in a reaction. Now see, normally in any chemical reaction, you have two or more than two reactants forming a product or more products. Okay. And in many reactions, chemical reactions, you have only one reactant, and such reactions are basically decomposition reactions. Okay, so in such reactions where there's only one reactant involved, in such reactions, there's no question of any limiting reactant, and there's no worry about this limiting reactant in such questions or such reactions. But in reactions where two or more than two chemical reactants are involved, there it may be possible that one of the reactant is limiting and the other one is not limiting. Now, if it is not limiting, we can call it as excess. So these two terms, limiting reactant and excess reactants, are to be understood very well in chemistry. Okay. So here we go with an example. When 3 moles of nitrogen combine with 6 moles of hydrogen to form ammonia, this is a chemical reaction he is talking about. Okay. This is a chemical reaction written in the balanced form. Okay. But before I come to this actual chemical reaction of ammonia and hydrogen forming, nitrogen and hydrogen forming ammonia, I want you to understand this limiting reactant in a different way. Okay, wherein I will talk about a simple uh, formation of a food product called sandwich. Okay, so suppose you want to make sandwiches. Okay, and you have say 20 loaves of bread. This is one of the reactant one, you can say. And suppose you have 200 grams of potato. Okay, this is say your reactant number two. Okay, or you can say the ingredients to make sandwiches you require is 20 loaf of bread and 200 grams of potato, right? This is going to give you certain number of sandwiches, right? Okay. Now, the rule is for making one sandwich, okay, for making one sandwich, you require 2 loaves of bread, okay, and say 10 grams of potato, okay. So this is a particular sandwich which involves only bread, loaf of bread and potatoes, okay, chutney and all that. Let us not talk about that. And this is going to give you sandwich. So if you want to prepare one sandwich as your product, the reactant or the ingredients needed will be 2 loaf of bread and 10 grams of potato, right? Now let us think of this in a logical way. Suppose I want to make 10 sandwiches. Suppose I want to make 10 sandwiches. Okay, how many loaf of bread for one sandwich? I need 2 loaf of bread. So for 10 sandwich I will need how many It will be 10 times 2, that is 20 loaf of bread. Okay. And how many potatoes I'll need? For one sandwich, I need 10 grams. So for 10 sandwich, again, I'll need 100 gram of potato. Right? Now, you can see here that if I go for preparing 10 sandwiches, okay, my 20 loaf of bread that I have in the initial stage, that is being consumed, okay, and potato is being consumed only half of the quantity. I had 20 gram of potato, but only 100 gram of potato has been used up, okay. So here what happens is, when I prepare 10 sandwiches, my loaf of bread is finished, or it is used up, or it is consumed. But my potato, still I have some potato left with me. Exactly, to speak in exact terms, I am left with still another 100 gram of potatoes. Okay. But can I now prepare more sandwiches? Because I have 100 gram of potato left out with me, can I still think of making more sandwiches, more than 10 sandwiches? No. Why? Because I don't have loaf of bread to make sandwiches. Okay. More than 10. Okay. So this is a situation where you can understand that this 20 loaf of bread, okay, is a limiting reactant. Okay. Is something which is limiting my number of sandwiches that I can make. Isn't it? So even though this 100 grams of potato is still left with me, I cannot make more sandwiches. So the maximum number of sandwiches that I can make is 10 sandwich, and this depends on, not on the potatoes, but on the loaf of bread. So loaf of bread happens to be a limiting reactant. Okay. So with this concept as a background, now let us come back to this particular chemical reaction where N2 plus 3S2 will give you 2NS3, and this is a very, very balanced equation. And in stoichiometry, you know that a balanced equation is something which is always needed. Okay. So what I mean to say is, if the equation is not balanced, you have to first balance it and then you have to proceed. So the balanced equation is this, like 1 mole of nitrogen plus 3 moles of hydrogen will give you 2 moles of ammonia. Next, this question says that 3 moles and 6 moles of nitrogen and hydrogen are given to you. See, the question is here. 3 moles of nitrogen is combining with 6 moles of hydrogen to form some ammonia, right? Now, if the question to your mind comes that how much ammonia will be formed, okay, or which is the limiting reactant here out of nitrogen and hydrogen, which is the one which is going to decide the how much ammonia is going to be formed. Okay, so if such questions comes to your mind, then the first step is to write the stoichiometric coefficients of this reaction. So the stoichiometric coefficients are nothing but, in a chemical reaction, in a balanced chemical reaction, whatever numbers or coefficients you see in front of the reactants and the products, those are known as stoichiometric coefficients. So you can see that in front of N2 you have 1. So 1 is the stoichiometric coefficient of nitrogen. Same way 3 is the stoichiometric coefficient of hydrogen, and 2 is the stoichiometric coefficient of ammonia. So 1, 3 and 2 are the 3 stoichiometric coefficients of the respective reactants and ammonia in this particular reaction. Once you have decided the stoichiometric coefficients, now what you do is to decide which is a chemical, which is a limiting reactant. Now see, one thing is sure, out of this two reactant, nitrogen and hydrogen, one must be limiting, the other must be excess. Okay. So limiting reactant is in general decided using this particular formula, that is given mole of the reactant divided by the stoichiometric coefficient of that reactant, isn't it? So in this case, you are given 3 moles of nitrogen, right? So if you want to find the this thing, there's something called limiting reactant constant, you can say. Okay, limiting reactant constant. Okay, and let us name that constant as K. So this limiting reactant constant K has this particular formula. Now this is your K. Okay, limiting reactant constant. Now this limiting reaction constant is given by this formula, given mole upon stoichiometric coefficient. So let us try to find out the LRC, limiting reactant constant K, of say nitrogen first. Okay, so the formula will be given mole upon stoichiometric coefficient. So given mole of nitrogen is 3 moles, and the stoichiometric coefficient of nitrogen is 1. So 3 divided by 1 is 3. So I am getting 3 as the limiting reactant constant K value for nitrogen. Fine. Now let me do one thing. In the same way, let me find out the limiting reactant constant, that is K, for hydrogen. Okay. So here in this case, I'll have to take how many moles of oxygen is given to me. So the question says that you are given 6 moles of hydrogen. Okay. So I'll take 6 upon, and what is the stoichiometric coefficient of hydrogen? It is given as 2. So 6 divided by, no, it's not 2. I think it's 3. Okay. So 2 divided by 3 should be equal to 2. So this 2 happens to be the limiting reactant constant for hydrogen. Now once you have found out the K values, that is the limiting reactant constant for both the reactants, whichever has the smaller value, in this case it is the hydrogen which has the smaller value, then that particular reactant is a limiting reactant. Okay, so this is the algorithm which will help you in finding which is your limiting reactant. So this can be decided now that hydrogen is the limiting reactant. Okay, this is decided. Why? Because the K value of hydrogen you got as 2, while the K value of nitrogen you got as 3, and the limiting reactant is that reactant whose K value should be less. Okay. So this is how you have to decide which reactant is limiting and which is in excess. So here for this particular question, your hydrogen is the limiting reactant, and your oxygen, sorry, hydrogen, it's not oxygen, nitrogen, okay, and nitrogen is the excess reactant, you can say. Okay. So in this today's session, I just taught you what is the meaning of this limiting reactant, and with a simple chemical reaction of nitrogen reacting with hydrogen to form ammonia, I have made you understand how to decide which one is a limiting reactant, nitrogen or hydrogen. So these steps are very important. The formula for finding the limiting reactant constant K is very important. So formula for K is given mole upon stoichiometric coefficient. You have to find for both the reactants the K value, and for whichever reactant the K value is smaller, that happens to be a limiting reactant, and the other one happens to be a excess reactant. Okay, so I hope this today's session must have made you understand what is the meaning of limiting reactant, and now in the next session or next video, I'll be picking up some few numericals, and I'll start explaining those numericals with you people. Okay, that's all for today, and goodbye. Take care, all of you. If you happen to like my video, my channel, please subscribe to my channel. Bye.